Hi, my name is Janani Jayashima, and this is my Physics 2211 Lab 1 for constant velocity. So for an introduction, the purpose of this lab is to observe Newton's laws of motion in the real world, and this experiment entails comparing constant velocity shown through a predicted model using glow script versus an experimental model measured in tracker. In this experiment, I rolled an 8-ball along a table, and the properties of Newton's second law, are also known as the momentum principle, is what is primarily observed in this experiment. To talk a little bit more about Newton's second law, it explains how the forces acting on an object can change the object's momentum over time. This is observed in the first equation. If there is no net force acting on the object, then the change in momentum is 0, which is observed in the second equation. Second equation showcases the momentum update formula, and if we were to replace F net with 0, it would result in initial momentum equaling final momentum, which results in no change in momentum. And with no change in momentum, the velocity of the object remains constant, which is shown in the third equation. So to get from the second equation to the third equation, we have to divide the momentum update formula by mass, as momentum equals mass times velocity, and that would result in the velocity update formula. And similarly, if we replace F net with 0, we would get initial velocity equaling final velocity, which is constant velocity, and that is what we are observing in this experiment. So for the system, we observe the system as the 8-ball and the surroundings as everything around the 8-ball, including the table, chairs, anything in the room, etc. So here's a video of my experimental model and my tracker analysis. I track the center of mass for each second, and as you can see, the position is being recorded, as well as a graph in the upper right corner. It is negative only because I'm rolling the ball from right to left rather than left to right, but a slope is still observed. So for my predicted model, I used glow script, and I made a few alterations to the starter code, starting with the initial position. I changed it to negative 0.0018 meters, as that is where I started tracking the position in tracker, because there was no force of my hand or anything. And for the velocity, I changed it to negative 0.7818, as that is the velocity I observed in tracker. For delta t, I changed it to 0.033, as it was 30 frames per second for tracking the position. And for the while loop, I changed it to 2.33 seconds, as that is how long the clip was. And for the updating the object's velocity, I made final velocity equal initial velocity, and to update the object's position, final position equals initial position time plus velocity times delta t. And here's a video of me running my code, and we can observe the position versus time graph, as well as the points at the bottom. And with the points at the bottom, as well as the points from tracker, I put them both into an Excel spreadsheet and created a position versus time graph showcasing them both side by side. We can make a few observations from this graph. As time increases, the points both diverge, starting at 0.561 seconds, overlap again at 1.914 seconds, and then diverge again at 2.079 seconds. This kind of goes to show that as time increases, the variance in the points of the experimental and computational model also increase, but overall both have about the same average velocity of negative 0.782 meters per second. The initial conditions for the experiment was 0 seconds, and the position vector was negative 0.0018 meters, as observed in the glow script code. For sources of error, we can observe that the experimental model becomes less linear as time increases. This is due to friction from the table. Any force that was acted upon the ball could have resulted in error, as there wouldn't actually be constant velocity, and any inaccurate center of mass tracking, as we are in tracker tracking the center of mass by hand, some human error could have resulted there. So for some what questions, if the axis were flipped, the x-axis were flipped, the slope would still be negative, but if the y-axis was flipped, the slope would be positive. Overall, there would be no change in magnitude. There would only be a change in direction, whether the slope is positive or negative and which way it's going. Is it possible to say how many pushes and pulls are added together to give zero net force? In the case that we observed, it would not be possible to observe all the pushes and pulls of the surroundings, as the surroundings we were in were infinite, so you can't really quantify all the forces in an infinite environment. And that is all I have for you today. Thank you so much and have a great day.